Okay, so in 6.7, we're going to look at different models, exponential and logarithmic models. There are other types of models also. And I just want to say this is not an easy thing to do. People in research and business and science, they gather a lot of data to create these models. But we're just going to look a little bit at some examples and some of the equations that we have and how these models work, okay? So we're going to talk about a growth and decay model. And we've seen this before. Y equals A naught e to the kt. And we might not have seen it exactly in that form, but I think we've seen it in that form. And y is representing the amount after so much time, after t time. A naught, that's what you start with. That's the initial amount. That we've seen before. E, well, we know a little bit about E. And the book mentions this is called, I'm going to write it for you and then I'll pronounce it. But it's pronounced Euler's constant. You know, I never want to say Euler because I don't think it looks like that, but that's how it's pronounced. And so we know a little bit about E. K, a lot's going to depend on K, but K is also another constant. And sometimes we have to find that constant. And then T is time. Now time could be in years, it could be in hours, it could be in seconds. Just depends on what you're working with. Okay, so we know a little bit about this model. We've used it before. We know that it graphs to be a one-to-one function. We know there's a horizontal asymptote at y equals 0. We know the domain is negative infinity to infinity, all real numbers, and the range is from 0 to infinity, but not including the 0. The x-intercepts, there are none. And the y-intercept, that one's kind of important to think about. It's going to be at 0 a naught. That's going to be your initial amount, so no time has passed. Okay, and then if k, now here this part's important, if k is greater than 0, then it's an increasing function. And an increasing function is going to look like this, okay? So it's going to be an exponential function. It's going up quickly. If k is positive, it's going to be an increasing function. If k is negative, then it's a decreasing function. And it looks like this. Something like that. You can draw better than I can, but something like that. So that's what we're looking at with these exponential models. Now, just a brief couple notes here. They talk about scientific notation. An example in the book they used was, it's some distance to some star, galaxy or something, and it's, I'm copying it down here, it's so long. It's that many kilometers for the distance. So they're talking in this, they want to mention that some of the data, we have very large numbers or very small numbers, and so we use scientific notation a lot of times to work with these numbers. Now, so quick review on scientific notation. If you were to write this number, very large number, in scientific notation, you would write it as 4.0113497.2. You wouldn't need these zeros at the end. Times, usually we use an x for times in scientific notation. 10 to the, now you have to count how many decimal places you moved. You start here, 3, 6, 9, 12, 13, to get that decimal behind the 4. So it's going to be to the power of 13, okay? Now remember, this number that you're creating in scientific notation, it has to be greater than 1. I don't know what we call that number. Call it n. It has to be greater than 1 but less than 10. Okay, so it could be like 9.9, but it couldn't be 99. Okay, so that's how scientific notation works. And then you count how many decimal places to get that exponent on 10. Okay, so it's 4.0113497 times 10 to the 13th power. That's the scientific notation. Now, sometimes they may say, well, we're going to round it to 3 decimal places or 4 decimal places or something like that. That's fine. And in your science classes, they're going to talk a little bit more about that and significant digits. But we'll just go with this scientific notation. Something they mention, though, is what's called the order of magnitude. The order of magnitude is the power of 10 in these situations where we're using scientific notation. So if they said, hey, what's the order of magnitude for this number? We would say it's 10 to the 13th power. So it kind of gives you a context of how large that number is. I don't think we're going to use that, but they mentioned it, so I thought I'd mention it too. Okay. In the next video, we'll see an example of how to work with an exponential model.